ladies and gentlemen, we're going to start question 2 now. On question 2, it gives us a graph and it wants us to write the equation of the function in vertex form. So, if you recall from your notes this week in class, the vertex form of a quadratic equation looks like this. And what we're going to do is start by finding our vertex. Our vertex is here on the graph, and it is right there. They actually give it to us. It's -2, -3. So we're going to take our quadratic equation and write that into the equation. Please remember that when I do, the value that I'm writing in is h, and k, we substitute it into our equation. And when I do that, remember when I have the opposite of h, that's going to give me a +2. The inside of the grouping symbol or that parentheses, the sign changes. So I have y equals a times x plus 2 to the second power and then -3. Now what we're going to do is solve for a because I don't know the a value. And in order to find the a value, you have to find, one other point. And the other point I'm going to use is actually going to be my y-intercept, which is here. My y-intercept is on the y-axis. I know you thought the solid line over here was your y-axis. That's not. That's our axis of symmetry because x equals -2. My y-axis is actually here, and my ordered pair is going to be 0, 1. Can you see that? I'm writing on my computer monitor. This is not a classroom, but that's okay. We're improvising. So, it's terrible. I have to clean my monitor. I have here 0, 1, and we're going to substitute that into our equation where I have 1 equals 8 times 0 plus 2 to the second power -3. Now we're going to solve for a. In order to do that, we start with parentheses first. Don't forget to add in the parentheses first. So I have 0 plus 2, which is +2 to the second power. And then next what we're going to do is do the exponent. Exponents go next. So 2 to the second power is 4. That's right, you got it. And then we're going to solve for a. That part you can do all by yourself. I'm not doing it for you. So once you find your a value, you should have a equals, I don't know yet. When you find that, you're going to place it here into your equation, and you'll have y equals something times x plus 2 to the second -3. Now, part B. Part B says to write the equation in standard form. In order to do that, we're going to look at your notes from class because we did it more than once. And what we're going to do is now convert that into standard form. So here was my equation from before, where you should have your a value in the blank line. Yes, I'm still not telling you what a is equal to. And so we're going to distribute our x plus 2 to the second. We expand it. So I have x plus 2 to the second times x plus 2. We remember in class we pulled it off to the side and we wound up with x because we split the first group. Split those two. So I have x times x plus 2 and then 2 times x plus 2. Distribute. Write your answer in up here. I should have something to the second plus or minus something plus or minus my constant and then -3. Don't forget I'm multiplying everything here times whatever your a value is. You're going to figure this out in a second. That's why I'm not worried about it. Once you do that, distribute your a value and then finish it off by subtracting 3 from your constant in the back. Then your equation will be in standard form. The last thing that we need to do is our end behavior. When we talk about our end behavior, we're asking what's happening at the ends of our graph. So before the axis of symmetry, going back this way, the graph is doing what? You got it. And now from here, after the axis of symmetry going this direction, my graph is doing what? Yeah, I know you know it. So write down what's happening before and after your axis of symmetry. So as x goes to -infinity, your graph is doing something. And then as x is going to positive infinity, your graph is doing something else. What's happening? Is it increasing or decreasing? In which direction? Okay, thank you very much.